Discuss Ravi.
Last class
Last class.
problems ఇంకా
Yeah.
ఎనర్జీ స్టార్ట్ చేశారు.
Only problems will discuss yesterday class.
ఎనర్జీ ఎనర్జీ
Yeah, yeah, energy. So some little bit of introduction is there about energy. Energy. Yeah, okay. Can you hearing me, Abhi?
ఎస్ సార్
Yeah, okay, very good, Abhi. Yeah, I can hear you, Abhi. Yeah, school ke lawa, Abhi?
ఎస్ సార్ వెళ్దాం.
Yeah, very good, Abhi. So last class we'll discuss, Abhi. So just a small introduction about the energy and so how many forms of energy is there? I will discuss, Abhi. So tell me what is the basic definition of energy, Abhi?
ఎనర్జీ ఇట్ ఈస్ అ ఫార్మ్ ఆఫ్ మోషన్ సార్.
Yeah, it is a form of motion. Okay. Yeah, it is a form of motion or some sort of work. So some sort of work is done by a object. So it is a potential or capability. It is a potential or capability for doing the work. So that is called as a energy. So that is called as a energy. So what are the forms of energies are there, Abhi, generally?
కైనెటిక్ ఎనర్జీ, పొటెన్షియల్
Kinetic
ఎనర్జీ,
energy, potential energy,
ఎనర్జీ, ఎలక్ట్రికల్ ఎనర్జీ.
thermal energy, and electrical energy. So here, Abhi, here, here, kinetic energy, it is in the form of energy in. So kinetic energy.
సార్
So what is the form of energy is there in kinetic energy?
మోషన్.
Yeah, it is one type of motion. It is a motion of energy. Next, the second one is potential energy. Potential energy, it consisting of
పొజిషన్ సార్.
position or stored energy. Position or stored energy, that is called as a potential energy. So what is meant by thermal energy? Sorry, thermal energy consisting of
హీట్.
a heat. It consisting of a heat. Next one is electrical energy. So electrical energy when we are experienced as a electrical energy. Okay.
ఎలక్ట్రికల్ ఎనర్జీ వెన్ ఇట్ ఈస్ ఎ ఫార్మ్ ఆఫ్ ఎ మూవింగ్ ఎనర్జీ.
Which one is moving away? Which they are moving?
ఎనర్జీ అంటే ఎలక్ట్రిసిటీ,
Yeah, electricity.
బ్యాటరీస్,
Batteries. Oh, no,
బ్యాటరీస్,
no, no, no. Charge carriers are moving.
బ్యాటరీస్.
So, due to charge carriers are moving, electrical energy is experienced. Away. Due to charge carriers are moving, electrical energy is experienced. Clear? Only due to charge carriers moving. Next, what are the basic units of energy? Avi? What are the basic units of energy?
ఎనర్జీ జౌల్స్.
Yeah, joules. What is the heat energy units? What are the heat energy units?
క్యాలరీస్.
Calories. Next one is what is the electrical energy units?
కిలో వాట్ పర్ కిలో వాట్ అవర్.
Kilowatt hour. Kilowatt hour. So I'll ask you one question, Abhi. 1 kilowatt hour equal to how many joules, Abhi?
10 power 3.
1 kilowatt hour equal to how many joules?
టెన్
One
పవర్ త్రీ
1 kilowatt hour equal to how many joules? Already we are studied in work chapter. Already we are studied in work chapter for the introduction class. For the introduction class, we are already studied 1 kilowatt hour equal to how many joules? Look your notes of it. Work chapter. Work chapter. There we studied. 1 kilowatt hour equal to how many joules? For the first or second chapter. So for the first or second class, we'll discuss basic units, work definition, then after work formula, then after work units. 1 kilowatt hour equal to how many joules? Okay.
Uh,
If you are not giving the answer, I didn't teach the class of it today. Refer your work chapter. I think we'll
what
discuss in first or second class in work chapter.
first fifth class లో మన
First or second
uh,
chapter. Or we'll discuss in power chapter also. You can refer your power chapter also. Somewhere we'll discuss definitely 1 kilowatt hour equal to how many joules. In work or power chapter, we'll discuss definitely. I know somewhere we are discussing 1 kilowatt hour equal to how many joules. I'll explain very clearly for the using of derivation also.
కిలో వాట్స్ నుంచి వాట్స్ కి చెప్పు
Kilowatts
కిలోవాట్ అవర్
నుంచి kilowatt hour నుంచి I'll converting into
కిలో వాట్ నుంచి వాట్ చెప్పారు
a kilowatt నుంచి watt కి everyone converts okay, no problem. But it converts into joules also. We don't discuss Avi. We are discussing Avi.
ఎస్ సార్ 3.6 into 10 power 6 dots.
Yeah, so why you are forgetting this Avi? 3.6 into 10 to the power of 6 watt second. So watt second it is equal to joules Avi. So why you forgetting Avi? How it is converting 1 kilowatt hour equal to 3.6 into 10 to the power of 6 joules?
1 kilowatt and hour, sir. 1 hour equals to
60 seconds.
3000,
Yeah, 3000. No, no,
3600.
no, no.
3 lakh 6, 60,000.
Yeah, look your notes. Tell me how it is converting. No problem.
Yes, sir. 1 kilo equals to 10 power 3.
Yeah, 1 kilo
One
equal to 10 to
hour
the power.
to
1 hour equal to
3600 seconds.
yeah 3600 seconds. 3600 seconds into 10 to the power of 3. So that will converting like this. That will converting into like this 3.6 into 10 to the power of 6 joules. So this is very important conversion of it. This is very important conversion. So we are frequently used in we are frequently used in electricity chapter also. We are frequently used in electricity chapter also. Conversion is very important. 1 kilowatt hour equal to how many joules? Not for kinematics. So in electricity also we'll use for this form. This conversion is help for doing the calculating of power or work. But don't just you remember so what we have discussed yesterday class. Refer your notes regularly, Abhi. Then only you have an idea for the subject, Abhi. Otherwise, everything is forget without remembering your notes. Abhi. Human brain is everything is forget for within the short span of time. Abhi. Human brain, or me and you also, without repetition, without remember of the notes, everything is forget, Abhi, within short span of time. So that's why regularly at least open one time, or one like a half an hour or 10 minutes. At least refer your notes very regularly. Then only don't like we don't forget all these concepts, Abhi. Otherwise, everything is forgettable. Human brain having a that good, very good quality, Abhi. Everything is forgettable with a short span of time. So even subject is also everyone forgetting with a short span of time, without remembering, without repeating, without studied, everything is gone. Okay, just you refer your notes away regularly, studied regularly. Okay, done. So work done by a spring. So this is also we'll discuss Abhi. So this is also it is a one type of application in work. So in a work, so spring. So in a spring, how much of work is experienced in a spring? I will discuss in in works after Abhi. So that's why I'm directly taking this formula Abhi. So what is the work done by a spring Abhi?
Uh, Work done by spin minus kx by 2.
Yeah, minus kx by 2. Excellent Abhi. Minus kx by 2. So x mean it is a distance between the final minus initial value. Okay. So yesterday we are doing this problem Abhi. Yesterday we are doing this problem. So there in a spring, there in a spring is given. So spring having a spring constant like 100 newtons per second, and it is displaced by 0.2 meters. How much of work is done in a spring? They'll ask to calculate it. So there also you are doing wrongly a bit. So like you are taking force is 100 newtons per meter. You are taking force is 100 newtons per second, newtons per meter away. So that is wrong. So always we know force units are only newtons. But you are taking, sir, force is given that force is 100 newtons per meter. You said like that yesterday. But if it does not mention like a spring constant, so directly given like this 100 newtons per meter. So just you remember what is the unit of this, what is the unit of this. You remember. Then after only you can take. So otherwise you can take like force. Is this is the force? Yeah, obviously your answer is wrong away. Work calculation is wrong away. Done. So here, so sometimes you forgetting, like you can use the formula also. That is the formula is W equal to half k into x square, yeah, half k into x square, k into x square. This is the work. So this is the work experienced in a spring. So here, what is the k? From this expression, what is the k? K equal to ఏమవుతుంది?
K equals to 100.
2 into W by, no. Just you can converting this formula. 2 into W by x square. 2 into W by x square. 2 is a constant, Abhi. 2 is a constant. So what is the units of work, Abhi? What are the units of work?
Uh,
Joules.
if into
No, units. Units of work.
yes,
Units,
joules.
joules. Units of work is joules. So x is a distance, Abhi. Distance in meter square. But here meter square is there. Like I'm writing x is distance, it is meter. So it is whole square, meter square. Now I'm writing 2 into joules per meter cube. 2 into joules per meter cube. So here I'm writing 2 into 2 into joules. 2 is a constant, no problem. Joules, joules per meter, joules per meter. I'm writing like this, meter into meter. Joules per meter ఏమవుతుంది అవి? Do you know joules per meter?
Joules per meter,
It is a force అవి.
energy.
Force. Joules per meter is a force. Force means ఏంటంటే it is Newton. Force means it is a Newton. Newton per meter. Given value is kV, Newton per meter. Spring constant units ఏంటంటే Newtons per meter. Spring constant units ఏంటంటే Newtons per meter.
అంటే
So
జౌల్స్ ఈక్వల్స్ టు న్యూటన్స్.
yeah, okay. I'll convert in a bit, no problem. I'll take one slide. I'll explain. Okay. Here we know how much of work is done by a spring. That is W equal to half into kx square. This is the work experienced in a spring. This is the work experienced in a spring. Then I can calculating the x k. So k equal to 2 into W by x square. 2 into W by x square. Yeah, 2 is a constant, no problem. Taken outside. So what is the units of work?
వర్క్ జౌల్స్.
Work is joules. Next. This is x is a distance. X is a distance. What is the units of distance?
మీటర్స్.
Meters.
మీటర్స్ ఆఫ్
So
కిలోమీటర్స్.
yeah, here meters. Abhi. This is meters. X units are meters or kilometers, no problem. Here x square is given. So here will become meter square. X square is given, meter square. Meter square is given. So now I'm writing 2 into 2 into joules per meter, 2 into joules per meter into directly I'm writing meter. ఇలా రాయొచ్చు కదా.
ఎస్ సార్.
Joules as it is I'm writing meter square, I'm writing meter into meter. Meter into meter. This is it will become 2 into joules per meter. Joules per meter it will become a newtons. It will become a newtons. Joules per meter it is equal to 2 newtons. Newtons. Newtons
అంటే
divided by meter.
న్యూటన్ న్యూటన్
Yeah,
ఈక్వల్స్ టు న్యూటన్ మీటర్ ఈక్వల్స్ టు జౌల్స్.
yeah. And no, Abhi. Joules per meter equal to newtons. Abhi. Joules per meter equal to newtons.
న్యూటన్ మీటర్స్. న్యూటన్ ఇంటూ మీటర్.
Joules equal to Newton meters. Joules equal to Newton meter of the. Joules equal to Newton meter of the. No problem. Joules equal to. Work equal to formula into work equal to ఏంటి? Force into
జౌల్స్. ఎఫ్ ఇంటూ
displacement కదా. F into S. What is the units of force?
ఫోర్స్ జౌల్.
Force units. What is the units of force? Abhi? Can you hear me?
వాయిస్
Can you hear
ట్యాక్స్.
me? Voice tracking. Okay, no problem. What is the units of force? Abhi?
ఫోర్స్ న్యూటన్స్.
Newtons. What is the units of distance?
మీటర్స్.
Yeah, here Newton's meter it is equal to joules or not? Abhi? Newton's meter it is equal to joules or not? Abhi?
ఎస్ సార్ జౌల్స్.
Yeah, means joules per meter equal to newtons అవుతుందా లేదా? న్యూటన్ ఈక్వల్ టు జూల్స్ పర్ మీటర్ అవుతుందా లేదా?
అయితే సార్.
Yeah, so that's why spring constant it is equal to 2 newtons per meter. Abhi. Then you can check like this also. So if you are not unable to determine the given data, so that time you can use like this. Abhi. Cross check the values, cross check the units. Whether you forget all the units are so very like sometimes it is very tough to determine the what is the given values. Then you cross check it away. So what is the given values? Just identification is very important in physics. Abhi. Identify the given data is very important. Then after problem is it takes 2 to 3 steps. Abhi you'll get the answer. Very easy. But identification is very important. Identification given data is very important. Abhi. Okay. So this is we'll discuss. Abhi. So this is the problem. We'll discuss in yesterday class. Next, mechanical energy. So mechanical energy, it is a rotational energy. It consisting of potential energy and kinetic energy. Potential energy and kinetic energy. So that we'll discuss away. Kinetic energy, it can write like this, half mv square. Today we'll discuss away. So how we'll get kinetic energy, half mv square. So what is the change in kinetic energy? What is the change in kinetic energy, Avi?
Delta K equals
Delta K equal
half
to half,
half of
half m
mv
of.
square of V final square minus V initial square.
Yeah, this is very, very important concept, Avi. So regularly JEE means law, number of questions are coming from this formula only. Okay, Avi. So just you note down these values, Avi. Note down this only. This is sufficient for units.
Okay, so
Okay, Avi. So now today we'll discuss very, very important concept, Avi. With this editing, work energy theorem. 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 Write down small definition, okay? I'll explain you. The work energy theorem. The work energy theorem. The work energy theorem. The work energy theorem states that the work energy theorem states that the work energy theorem states that the net work done on a object 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 is equal to the is equal to the is equal to the change in is equal to the change in its kinetic energy change in its kinetic energy change in its kinetic energy change in its kinetic energy. Yeah, tell me, Abhi. So work energy theorem states that,
states
tell me
that
what
the net work done on an object
work done on
equals
a object.
change in kinetic energy.
Yeah, change in kinetic energy. So means ఏంటంటే the work done it is equal to change in kinetic energy. So work energy theorem states that the work done on a object it is equal to change in kinetic energy. So for example here, like one body is there, like m is body is there, it is moving on some velocity v. So it is push like you are applying the force in like this direction. It is displacing from here to here. It is displacing from here to here. here to here. It is displaced from here to here, Abhi. So initially at rest, Abhi, it is moving on some velocity. So it is moving on some velocity means it is moving on some velocity means it is in kinetic energy. Like it is in motion away. It is in motion means it is having a kinetic energy. It is having in a kinetic energy. That kinetic energy it is equal to that kinetic energy it is equal to work. Here developing work is a kinetic energy. So that is the work energy theorem of it. Clear? So means ఏంటంటే here like car is there అవి కార్ ఇనిషియల్లీ రెస్ట్ లో ఉంది. This is the car అవి కార్ ఇనిషియల్లీ రెస్ట్ లో ఉంది. It is accelerating from rest to like it is accelerating from rest to some speed అవి it is accelerating from rest to some speed. It is accelerating from rest to some speed. So that is having a kinetic energy. That is having a kinetic energy. That kinetic energy of the machine, that kinetic energy of the engine, it is equal to work. That is the work energy theorem of it. So I'll explain very clearly. I have no problem. అర్థమైందా? Do you have an idea? Work energy theorem అంటే
సార్ కొంచెం.
యా మీన్స్ ఏంటంటే ఇప్పుడు కారు రెస్ట్ లో ఉంది అవి కార్ ఏంటంటే ఇనిషియల్ గా రెస్ట్ లో ఉంది. యూ కెన్ అప్లై. సో అంటే మనం ఏంటంటే కార్ రెస్ట్ లో ఉన్నదాన్ని ఏంటంటే నువ్వు స్టార్ట్ చేసావు అవి స్టార్ట్ చేసావు అంటే యాక్సిలరేషన్ తో స్టార్ట్ అవుతుందా లేదా? సమ్ యాక్సిలరేషన్ ఉంటుందా లేదా
ఉం-
స్టార్ట్ అవ్వగానే?
ఉంటుంది సార్.
యా స్టార్ట్ అవ్వగానే సమ్ యాక్సిలరేషన్ తో స్టార్ట్ అవుతుంది. అది 5 meters per second 10 meters per second అని ఒక యాక్సిలరేషన్ తో స్టార్ట్ అయ్యి ఏంటంటే ముందుకెళ్తూ ఉంది అంటే మోషన్ లో ఉంటుందా రెస్ట్ లో ఉంటుందా? వెళ్తుంది అని అంటే ఇట్ ఈస్ గోయింగ్ అప్. మోషన్
మోషన్.
మోషన్ మీన్స్ ఇట్ ఈస్ ఏ కైనెటిక్ ఎనర్జీ. కైనెటిక్ ఎనర్జీలో ఇట్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ మోషన్ కదా. కైనెటిక్ ఎనర్జీ ఇట్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ మోషన్ ఆర్ నాట్?
మోషన్ సార్. ఎస్.
యా సో మోషన్ అంటే ఎవ్రీ బాడీ సో మోషన్ లో ఉందంటే దట్ ఈస్ హ్యావింగ్ ఏ కైనెటిక్ ఎనర్జీ. దట్ కైనెటిక్ ఎనర్జీ ఇట్ ఈస్ ఈక్వల్ టు వర్క్. దట్ కైనెటిక్ ఎనర్జీ ఇట్ ఈస్ ఈక్వల్ టు అవర్ వర్క్ అవి. సో దట్ ఈస్ ద స్టేట్స్ దట్ వర్క్ ఎనర్జీ థియరీ. సో మీన్స్ ఏంటంటే హియర్ దిస్ ఇస్ ద పాత్ అవి దిస్ ఇస్ ద పాత్. So this is the path. Now you are starting from A to B. Now you are starts from A to B. B is there. This is the ending of the path. So somewhere you are taking like some path. Here you are taking some path, that is total length of the path is x. So small length is dx. Small length is dx. Sorry. So from A to B, so force is constant or variable? Abhi?
వేరియబుల్ సార్.
Yeah, variable. Definitely force is variable. Abhi. So definitely force is variable. So here we know formula. So what is the formula of force is variable? What is the work formula?
ఇంటిగ్రేషన్ ఆఫ్ ఫైనల్ పాయింట్ టు ఇనిషియల్ పాయింట్.
Excellent, excellent, excellent,
ఎక్స్
Abhi.
ఇంటూ డిఎక్స్.
Yeah, very good, very good, very good, Abhi. So we know basic formula and the work. Yeah, that is dW. Change in work it is equal to change in force. Change in force into displacement. That is in dx. We know we are doing some lot of problems about this formula in our work chapter. So here both side, this is the dw, this is the f into dx. Abhi. So what is the dw? Integration of dx ఏమవుతుంది?
ఇంటిగ్రేషన్ ఆఫ్ ఎక్స్. ఎక్స్
X. X. Integration of dx will become x. Integration of dw,
ఉండబోయే.
yeah, w. So w equal to f into dx. W equal to f into dx. F into dx. F into dx. So here force having a mass, or we know formula force having a mass, that mass is also what is the formula force having a mass of it? Mass into acceleration.
యాక్సిలరేషన్.
Mass into acceleration. That's substituting in the place of it. That is mass into acceleration into x in the place of force. In the place of force, I substituting m into a. M into a. We know that Abhi. We know that. We know that. We know that Abhi. We know that acceleration, how many formulas are there, Abhi, tell me. Recently, we'll discuss Abhi acceleration formula. But tell me, so what is the basic formula of acceleration? What is
Delta
meant
V
by
by delta
acceleration? Excellent, excellent, Abhi. Delta V by delta T means ఏంటంటే change in velocity. Change in velocity with respect to the time. Delta or dv, no problem. So this is I'm writing like this also. Yesterday I'll derive it away. dv by dx I'm writing, dividing and multiply with the change in distance by dt. It is a expression will become changes in constant away. I'll derive it in and multiply with the same quantity.
changes.
Changes are yesterday we'll discuss this application. dv by dx I'm writing. dx is multiplying
dv
and
by
dx is
dt.
dividing. Yeah,
Yes,
I
sir.
will.
Yes, sir. Dx
Yeah,
dx cancel.
yeah. dx is cancelled. Now you will get dv by dt. So that this is your LHS dv by dt. No problem. So here Abhi, I am writing dv by dt, dv by dx. So dx is a change in velocity, change in distance with respect to the time. What is happening, Abhi? Change in distance with respect to the time. Rate of change of distance
Change
means rate of change of distance. It is
speed
called this v.
speed
V. So that is velocity. So I am writing v into dv by dt, dv by dx. That is the acceleration formula. Yesterday we'll derive it, Abhi. Not for yesterday. Maybe like day, day before yesterday. Maybe. Day after or day before yesterday we'll discuss this, Abhi. Acceleration equal to v into dv by dx. Okay, Nabi.
okay, sir.
Yeah, just in the place of a, in the place of acceleration, you can substitute it, Abhi. In the place of acceleration, we are substituting, we will get some work equal to integration of m into a into dx. M into a into dx.
Yes.
What is the a of it? Acceleration equal to?
V into dv by dx.
Yeah. So this is mass into v into dv by dx
dx.
into dx. So then after, so here any possibility of cancelling terms?
dx cancel.
Dx is cancelled. So integration of m into v into dv.
M is
Excellent, excellent, Abhi.
uh,
So m is outside of the integration. Integration of v into dv.
dv also.
No, no. Yeah,
V
here I'm
square
writing.
by 2 is a 2.
Yeah. This is dv. So integration of v into dv.
V square by 2.
Excellent, excellent. V square by 2. So v square by 2. So that is yeah, v square by 2. Abhi. M into v square by 2. It is equal to work. Work equal to, now I'm writing like this, half mv square. Half mv square. Half mv square. This is the work. Work equal to half mv square means what, Abhi?
Half m square.
This
Half
is
work, sir.
which work? This
Work
is
done
this is
variable.
what is this?
Variable work.
What is this?
Kinetic energy.
Kinetic energy. So half mv square is a kinetic energy. So your work is kinetic energy or not, Abhi?
Yes, sir. Motion.
So okay, I'll prove it, Abhi. Work equal to kinetic energy equal to half mv square. I'll prove it. But work energy theorem is also states that work energy theorem is also states that work energy theorem is also states that the net amount of work it is equal to kinetic energy. The net amount of work is equal to kinetic energy. So now you are moving from A to B. Now you are moving from A to B. So you can consider a small length that is in dx. Total length is x, small length is dx. So now we are calculating the small length dx work. So that work equal to kinetic energy. That work equal to kinetic energy. Work energy theorem states that any body starting from rest to motion, any body starting from rest to motion, so that body consisting of a kinetic energy. That kinetic energy it is equal to your work. Anybody. So if you cannot have like for example here 10 kg, 10 kg of mass of body is there, Abhi. So 10 kg of body of mass is there in your class, in your study room. In your study room, 10 kg of mass of block is there, Abhi. This block is there. Now, if you it is in initially rest, Abhi. It is in initially rest. You cannot apply any force, Abhi. You cannot apply any force. It is in rest. What is the net amount of work, Abhi, here?
Work zero, sir.
Yeah, work is zero. Work is zero. Work is zero. You can apply some force, Abhi. You can apply some force. You can apply some force. You can lift it, and you can apply some force. You can lift or you can move in some here to your study room to kitchen. Your study room to kitchen. Your study room to kitchen. How much of work is done, Abhi, here?
Uh, Distance or
Yeah, distance. So means your work is that is W equal to F into S. Your work is that is W equal to F into S. So it is moving from rest to somewhere, Abhi. It is moving from rest to motion. Moving means rest to motion. Motion means it is a kinetic energy or potential energy.
kinetic
Motion.
energy.
Kinetic energy. So here kinetic energy it is your work or not, Abhi? Here kinetic energy it is your work or not, Abhi?
Work, sir.
Yeah, work. So here experience అయిన వర్క్ ఏదైతే ఉందో ఆ వర్క్ అనేది kinetic energy అవుతుంది. So that is the states that kinetic energy theory ఉంది. Okay, copy all this, Abhi. Copy all this, Abhi.